Hello, my name is Marco Machito from Siama Systems, and today I'll be demonstrating how to set up synthetic traffic generation, filters, and collectors on the Prova. My test setup is pretty simple. I'll be connecting port 1 directly to port 2 with a duplex fiber pair. Port 1 will be generating the synthetic traffic, and port 2 will be filtering and collecting that synthetic traffic so I can obtain performance measurements such as loss, latency, and jitter. So the first thing I'm going to do is log into my system and check that the ports are set to Gena mode. So we're using port 1 here connected to port 2, and we're going to generate synthetic traffic between the two of them. This is all done in Gena mode. So to verify that the ports are in Gena mode, you click port mode, and you can see here that port 1 is indeed in Gena mode, and so is port 2. Now to make my life a little bit easier, I'm going to just copy the MAC address of port 1, and I'll show you why in just a second. So let's go ahead and set up a stream. So port flows, and we'll create a stream instance, and we'll call that stream instance Marco stream 1. Let's say it's continuous. That's fine. I'm going to generate it at, I don't know, 80% of line rate at 10 gig, and you can see that translates into that many packets per second. I'm going to choose a fixed frame size of 512 bytes and a PRBS32 pattern. And here's where I needed the MAC addresses. So even if this went through a switched network, we want to have unicast synthetic traffic generation, right? So if I'm generating from port 1 to port 2, my source address is that of port 1. So it's the MAC address that I just copied. So I'll go ahead and I'll paste it here. And we know that the MAC address of port 2, which is the destination address, is just port 1 plus 1. So it's going to be 000162. So there you go. If I wanted to, I'm going to go ahead and click the apply here. You don't need to click the apply until you configured everything that you need, all the headers you want in your stream. But I just did it here just to show you how it clears the header view. If I want to add a VLAN tag to this, I want you to notice below in the header view that the bytes that I change by adding a C tag get highlighted in yellow. So 81000000, and you can see here I'm going to put in VLAN, I don't know, 1000, which translates to 03E8. Let's go ahead and add IPv4. I'm going to say my source address is 1.1.1.1. My destination is 2.2.2.2. It's fine because I'm not going through any routed network, but you want to, put in appropriate IP addresses if you're going through an IP routed network. And layer 4 here, we're going to insert some UDP. So let's say source port 1 and destination port all 2s, and I'll go ahead and click the apply button. So I've built out this header, and you can see it here in hex. We want to collect performance information. So if you want to collect performance information, we need to insert the Siama proprietary test header in the packets being generated so that the collector N can extract that information and look at things like latency, calculate jitter, and look at the sequence number of the packets to determine if there's lost packets or out of order packets. Now, the Siama test header gets inserted after the layer 2, layer 3, and layer 4 header that you might insert using these tabs. So you just go over to test and you turn on the Siama test header, and that's where it inserts itself. You can see here. Now the sequence number actually gets generated by a field puncher, so we can assign it to a field puncher. So we're going to assign it to field puncher 1, And you can see here, field punch 1 is now has the assignment of the test sequence number. We'll make that 32 bits wide, starting with the least significant bit, and it'll increment by 1 for every packet transmitted by the port. So we keep this on stream packet count. Great. So now we have this packet that we've created with source destination MAC addresses, a VLAN, CVLAN tag, and we put some fake IP and UDP in it. And we've also inserted the CIAMA test header. So that's exactly what we want. And we're going to generate that from port 1 to port 2. So to associate the stream, see here at port 1, I'm going to click and create a flow instance. So the flow is the logical entity that schedules streams for transmission out of port. I could, of course, have multiple streams here, and I can have multiple flows up to 32 associated with port 1, right? For this example, I'm just going to actually use a single stream and a single flow. So I'm going to go ahead and I can just grab this, drag and drop it here, or equivalently, I could choose to assign that stream by choosing it out of a list here and clicking add. Okay, so I just click on the plus for flow 1 and add it to that flow. So if, like I said, if I had multiple streams, I could add it to this flow just by dragging and dropping if I wanted to. And what that means is that it will play Marco stream first, then when that completes, play stream 2, then play stream 3. The little gotcha here is the fact that Marco stream, remember we set it to continuous, so it'll never stop. But if you had a finite packets of Marco stream and a finite packets of stream 2 and stream 3, you'd play one after the other. If you wanted to multiplex streams out a port, what you do is you add multiple flows. And what that'll do is basically then you can assign streams to flows, and each one gets bandwidth scheduled out the port. And you have to be careful not to oversubscribe the port, so you're not transmitting or attempting to transmit more traffic than the line rate can actually physically handle, right? Okay, we'll just get rid of these. We don't need these. So we'll go back to that simple example with a single flow and with a single stream. Okay, now that we have traffic generation set up, we should be able to generate some traffic from port 1 to port 2. What I like to do is keep a tab open in my Chrome browser for the config and keep another tab open with the home screen at all times. To do that, all I need to do is click on the user icon here and select new tab, and it'll open up another tab with the same session. I usually like to put that in the leftmost position. So now I have two tabs open, and from the home screen should be able to generate some traffic to port 2. And you can see here, generate 80% of line rate, that's C-tag traffic between port 1 and it's being received at port 2. Can stop that and reset the statistics. There you go. Okay, now I'd like to collect some performance data on that synthetic traffic being sent. To do this, I'm going to need to create a filter on port 2. So if I go to port 2, I create a new filter instance, and this filter instance will match Marco's stream 1. Okay, I'll enable that. So we need to tell this filter where the CIAMA test header is. So which bits should it be looking at to extract that hardware timestamp and sequence number information. So we created a packet with a CVLAN tags. So we turn CVLAN on, and then there was IPv4, followed by some UDP, followed by the CIAMA test header. So Now the filter that's been instantiated on port two's receiver will look for the test packet bytes in the right location within the frame. So we'll go ahead and accept that. Now, if you noticed, I didn't specify particular bits in any of these fields for layer 2, layer 3, or layer 4. So essentially, the filter is promiscuous. So any packet with that enters into the port, it'll jump to the byte, which is the start of the CIAMA test header, extract the bytes for the test header, and use that in its performance management calculation. If I wanted to, I could filter only specific packets. So, for example, I could filter packets to make sure they're the right packets that have a source address of 61 and a destination address of 62, right? So to do that, I'll put those addresses in the fields and I'll mark the mask as all F, right? So the mask gives you the power to mask the bits, and so therefore you could look at ranges of MAC addresses. You could look here in this case for specific unicast addresses, so on and so forth, right? And you can do this for multiple fields within layer 2 MPLS, layer 3, and layer 4. Okay, let's leave it like this for now. Okay, so if this field is set up correctly, I should be able to show you that I'm matching packets here, right? Um, so in the general tab of the filter, um, the way to associate it with a collector is going to be using its disposition. So let's go ahead and create a collector instance so we can collect that data. We're going to call it collector 1. All I need to do is create the instance. And now I'm going to associate it with the filter. So um, I'm going to peer. So this is a logical peering to a collector. And now you'll see that collector 1 will appear in the drop-down list. So now everything that's matched will peer with the collector endpoint. So the peering is a logical thing. The collector will then extract the performance data and will start to collect statistics, frame loss, latency, jitter, out of order frames, and the like. Okay. You also notice that here, every successful match will make the peered packets counter increment by 1. So you understand that there's a successful match and then it's being peered to that collector. So if I start generating synthetic traffic here and go back to the filter, you see that actually, yes, we are indeed matching those packets and they're being peered. And if I go to the collector, we can actually start this collector and say enable, and it will start collecting performance data. So this is the frame loss screen, and you can also set up frame transfer delay and frame delay variation um, settings with thresholds and the like. You can see here that it's actually collecting that performance data, and after you're done, you can actually export the performance data by simply clicking the up arrow, and you'll export those results in a report that's CSV format. Okay. So you can see the performance data there. Okay. So I'll go ahead and stop the traffic generation. And this is so at this point it's just a unidirectional test. If I wanted to make this a bidirectional test, well, I basically needed to replicate the same config but have the synthetic traffic generation or the flow be generated out of port 2 and then have the filter and collector at port 1. Okay. Um, Let me show you something else that's kind of neat. Let's keep that on the home screen. I'm going to go port, and I'll show you filters. So instead of peering, let's go ahead and set a loopback. So anything that matches this filter will be looped back by port 2 and head towards port 1. So if I reset the statistics, get rid of that, you'll see here now that the packets being generated out of port 1 are received by port 2, matched by that filter entity, and looped back from port 2 to port 1. Now, uh, currently they're being looped back unchanged, but I could also loop it back with some action. So we can do match action. Let me stop this for a second. And you could loop it back and swap the destination and source addresses uh, just by clicking here auto reply host and accepting that. Then you'll have the source and destination MAC addresses swapped. So we have the packets being generated by port 1 being matched by the filter on port 2. So this filter, you can see, is matching and then looping back the packets. And we set the mode to auto reply host. So we have a match and we have an action. And the action is to swap the source and destination MAC address. If there's an IP address, to swap the source and destination IPs. And if it finds TCP or UDP port numbers, it'll swap those as well. So I'm going to prove that to you, that the frames being generated here from port 1 are matched. The MAC addresses, IP addresses, and port numbers are swapped, and then they're coming back here transmitted from port 2 to port 1. Now the way I'm going to do that, the way I'm going to prove it to you, is I'm going to capture the traffic coming in or being received by port 1. To do that, let's go ahead, let's stop the packet capture here for a second. To do that, what I'm going to do is create a capture buffer. So I go port capture, and on port 1, I'm going to go ahead and create a buffer instance. Now the buffer that I'm creating is a gig in size. I'm going to make it real small. I'm going to make it, well, just about a megabyte in size, just so I can capture a little bit of that traffic and show you what that looks like. And I'm going to assign it to port 1. So port 1 gets buffer 1, and the next thing we're going to do is create a filter for port 1. That's a promiscuous filter. We'll enable that, and we'll so every packet that it receives will capture, and we'll capture that in the capture buffer. Okay. So just to recap here, port 1 is generating Marco stream number 1. Remember that it had destination address 62, source address 61. It had source address all ones, destination address all twos, and it even had a UDP header with source port all ones and destination port all twos. Now we're going to see those fields get swapped by port 2 before being transmitted back to port 1. I'll go back home. I'll reset the counters here. And what I'm going to do is I'm going to click the record or start packet capture. So this port is now going to capture any packets that are matched by that catch-all filter. So I'll start packet generation. The packets get transmitted to port 2, get looped back, and come in on port 1. You see that that 1 megabyte buffer was able to capture 1,985 packets. Right? So I can go ahead and export this capture and show you by just decoding Wireshark that, remember, we had source address 61 and destination address 62. So we should have the opposite here. And you can see that at the Ethernet layer, we have destination address now 61 and source address is 62. Now, the IP source and destination, you can see here as well. The source, instead of being 1.1.1.1, is 2.2.2.2. And the source port is all twos, destination port is all one. So we swapped all these fields before sending it back, and that's how you can perform a smart loopback in a very easy way using the appliance. The collector results in the previous experiment were pretty boring. We only had a fiber connecting port 1 and port 2, so we had essentially zero latency, no jitter, and no loss. I'd like to revisit this test setup to make things a little bit more interesting. So let's generate traffic from port 1 to port 3. We'll instantiate an impairment entity between port 3 and port 4. That impairment entity will add latency, jitter, and loss to the flow. Port 4 will then send that traffic back to port 2 to the same collector on that filter so that we can collect the performance data, and we'll see something a little bit more interesting this time. So I've gone ahead and reconfigured my Prova. I've connected port 1 to port 3 and port 4 to port 2. So the synthetic traffic will be generated from port 1 to port 3. Port 3 will receive it. Through pair port mode, we'll exchange those packets with port 4 going through an impairment entity. Port 4 will then transmit that to port 2, where we have the collector entities, which will collect the performance data. So the first thing I need to do is set up a buffer for port 3. To do that, I'm going to click Port, Capture, and create a new buffer instance. I'll call it port 3 buffer. And I'll assign this buffer to port 3. Now, this is 1 gigabyte in length, which is plenty for our application. We just want to add, some milliseconds worth of delay here. The way we bridge port 3 and port 4 is through playback mode. Okay, so to do that, go to port 4 and change the playback control state to enabled. So changing it to enabled will allow playback control, and the source is not its own buffer, but rather the paired port buffer, meaning the buffer of port 3. Before we add jitter here, just keep that disabled, and let's say we'll add, 15 milliseconds of delay, and you can apply those changes. So that gives port 4 the ability to get its data from port 3 through, you can consider it a logical backplane. Okay, so there's a connection between port 3 and port 4 that's enabled by this mode. Now that we have the port 3 buffer in the forwarding state, we just have to bind a filter to it. So let's go port, filters, port 3, create a filter instance, and we're going to go ahead and enable capture. So it's as simple as that. It's a promiscuous filter, and that's what's going to fill port 3 buffer. Let's go back to the home screen. Now, to create that paired port bridge between port 3 and port 4, all we have to do is get port 4 to start reading from the port 3 buffer. To do that, press the play button. You'll see that it also highlights the receive of port 3 in red to show you that these two have been bridged. So anything received by port 3 will go to port 3 buffer, and then with a 15 millisecond delay be transmitted out port 4. Now that port 4 is, remember, connected to port 2, right? So if I generate synthetic traffic from port 1, we should see it go through the impairment entity and be received by port 2. In fact, that's what's happening. So we're going from port 1 through the impairment entity, port 3, port 4, back to port 2. And remember, we have a collector set up on port 2. So let's go check out the collector. So port, collectors, port 2, collector 1, and you can see here that the min, average, and max frame transfer delay or latency is 15,000 microseconds, which is 15 milliseconds. I've stopped the synthetic traffic generation from port 1, and I've stopped the paired port mode and reset the statistics. What I'd like to do now is add some frame loss as part of this impairment. To do that, I'm going to click port and then impairments and port 3, and I'm going to add an impairment entity. So what this does is it marks frames for discard. We'll just leave the default values. This means that for every 100 frames that match the filter, it'll mark 1 for discard. So then I'll go back to filters, port 3, and we're going to go ahead and peer with that impairment entity that we just created. So that's great. And now as you're capturing frames into the buffer, those that are marked for impairment, so 1 out of the every 100 that we're going to mark for impairment, we enable the discard of that. I click apply, and now we can go back to the home screen, re-enable the pair port mode, and now here I'll go to filter flows, and the stream that I had set up. Now I'm going to show you here that out of every 100, I'm going to generate 100 packets. We should be discarding 1. So if I click play, we'll send 100 packets, and you can see here we received 99. And if I press play again, we'll see 198. So we're discarding 1 out of every 100 packets. What I'd like to do here now is go back to the stream for port 1 and re-enable continuous mode. Great. And now we can play continuously. Whoops. Forgot to apply that. I'll go ahead and play continuously. And we go check out our collector again. So if we go back to collector on port 2, we'll re-enable our collector, start the statistics from scratch, and you can see here that we are getting some frame loss, and the frame loss ratio keeps on going, well, hovering around 1%. So 1 out of every 100 frames would be 1%, right? It shows you here even the gaps. A gap is any period of frame loss, so that one frame makes a largest gap of 1 packet, right? And the delay measurement, again, we can see that we're precisely at 15 milliseconds. So I hope you found this video useful. If you have any questions or comments, feel free to email us at support@siamasystems.com.